This is the video for task 14. In task 14, we're going to calculate the incremental net monetary benefit for our probabilistic analysis. So on the right of my screen, I have the incremental net monetary benefit sheet open, and you can see that just like in the previous couple of tasks, we have some new rows that have appeared on the sheet in question, and we're going to use those rows to do the corresponding calculations for the probabilistic analysis. There's a real pattern over the last few tasks. We just have to work our way through each of these sheets doing the probabilistic calculations. But recall on the discounting sheet, we had 4 big tables to complete. We had the costs for A, the costs for B, the qualies for A, the qualies for B. And then on the previous sheet, the incremental outcomes sheet, we only had 2 tables, right? We had the incremental costs, incremental qualies, and now on this sheet we just have 1. So our work is getting easier as we go through these tasks. So how do we calculate the incremental net monetary benefit of treatment B? And if you recall, we did that mini exercise back in part 1, and we ended up completing cell D23. You can see the formula at the top. Essentially what we're doing here is we're taking the incremental qualies for treatment B and multiplying them by the threshold to value those qualies in monetary terms, and then we're subtracting the incremental costs of treatment B. We're going to do exactly the same thing here. We just need to be careful to use those probabilistic values. So we're going to say equals, and then we're going to go just back to the incremental output sheet, and we need the incremental qualies for cycle 1 for iteration 1, and that's in BO38. We're then going to multiply that by the threshold, so S underscore threshold. And then we need to subtract the incremental costs. And that's back here in column D. So incremental costs in cycle 1, iteration 1. Okay, that looks good to me. I'm going to press enter. And that's been marked over. It's been copied over, I should say, and marked correctly. So it's happy with that. And then in step 14.2, we're going to do the mean, just like we have in the last couple of tasks. I'm going to type that again. So equals average. Click on the first cell. So that's D38. Hold down Control and Shift, press down, and then close the bracket. There we go. That should work. And then we need to do the percentile again. So good practice to keep doing this. Percentile, open a bracket. The range is from D38. Hold down Control, Shift down, close. Sorry, we don't close the bracket yet. We do a comma. We do a comma because in the percentile function, we also need to provide a second parameter, which is the percentile in question, which is C34. We then close the bracket, and then we think carefully about the dollar symbols, because this is going to be copied down by 1 row. So we need to lock D38. We need to lock the 38, and we need to lock the 1037. Don't lock the D, because this will be copied across the columns. And then the C34, again, we don't want to lock 34 because we want that to turn into 35 when we copy this down. But we do want C to remain as the column when we copy this across. So we lock the C. There we go. Okay, and then we move on to step 14.4. Calculate the total costs. Sorry, not the total cost, take the total across all cycles for each iteration. So if we move across here, we have this total cell here in BM38. And again, we should be able to just copy the formula from BM23, copy, and paste it in here. Yeah, it likes that. Okay, so this is now the last step of task 14, the expected incremental net monetary benefit. So there's another blue cell here, and as it says in the instructions, I'll let you read this in your own time, but this is the most important blue cell of all. So this cell here is the mean of the incremental net monetary benefit, what we often call the expected incremental net monetary benefit, mean and expected being interchangeable here. So it's been given the name R mean inc net monetary benefit. And this is probably the most important calculation in the entire model. That one cell alone tells us whether treatment B is cost effective or not, given the current inputs, given the current settings. Okay, so because it's negative, treatment B is not cost effective, which means that treatment A is cost effective. If this cell was positive, then treatment B would be cost effective and treatment A would not be cost effective. And if we were to change the input parameters or the settings, for example, the cost effectiveness threshold, if we were to increase that substantially, well, then this cell would become positive and treatment B would be cost effective. So this is the most important cell in the entire model. And this paragraph here just emphasizes how many calculations have gone into this one cell, right? So all of those inputs that we put in on the input sheet, all of those distributions that we've put in, everything you put in on the model sheet, all the discounting, all those discount factors, all of that, the calculation of the incremental outputs, and then the calculation of the incremental net monetary benefit, which took into account the cost effectiveness threshold. And then it's been totaled across all the cycles, averaged across those 1,000 simulations. There's an enormous amount of calculation that has gone into this one cell. And this is the cell that tells us whether treatment B is cost effective or not, given the current settings, the current current inputs. And when we see that it's not cost effective, that doesn't mean that we just give up on treatment B. What it means is, well, perhaps a price reduction is in order for treatment B, in order to get that value in the blue cell to make it positive, right? Have a little think about that cell and how it's been calculated. And when you're ready, tick the checkbox on the left here on the setting sheet, on the instruction sheet, and then we are ready to move on to the next task. Okay, so the next task is calculating the expected value of perfect information, and I'll come to that in the next video, and I'll see you there.